Let us study about the velocity magnification for spherical mirrors. This is the magnification used to relate velocity of image and that of object. Now there are two cases we are going to study here. Case one is one object velocity is perpendicular to principal axis. So if there is a situation in which we are given with a concave spherical mirror, or even the relation is valid for convex also. Say we are given with an object which is at a height x above the principal axis and moving perpendicular to principal axis with the velocity v. And corresponding to this object, if the image is obtained here which is at a depth y below the principal axis, then obviously as object is moving above, image will move in opposite direction with the velocity say vi. So object is located at a distance u and image is located at a distance v from the pole of mirror. Here we know that magnification of image with respect to object which is written as m, it is given as v by u. And obviously this is equals to y by x, which are the ratio of height of image and that of object from principal axis. Now here we can write as object velocity is vu. This can be written as dx by dt, and image velocity, if we wish to calculate, this is written as vi, which will be dy by dt. And here we have y is equals to mx. If m is the magnification, the value of m is v by u we already have. So in this situation the velocity of image we can write as dy by dt, which is m times dx by dt. So this can be written as velocity of image is m times the velocity of object, and this is the relation which is valid when vu and vi are perpendicular to principal axis. So the same relation holds in velocity magnification which we use for the magnification of the height of image with respect to object perpendicular to principal axis. In continuation, let's study about the case 2. One object velocity is along principal axis. In previous case we have discussed the velocity magnification when object velocity is perpendicular to principal axis. So if there is a situation in which in front of a concave spherical mirror there is an object located at a distance u and at a distance v from the pole, image is obtained. But here the object is moving say with the velocity vu along the principal axis, then we know well that if object is moving away, image would be moving in opposite direction vi. Now in this situation, say object is located at a distance x from the pole. Here we can take u as x and say it displaces by dx. Then if v is taken as y, we can say correspondingly image will be displaced by a distance dy in opposite direction. So as we already discussed in longitudinal magnification that as we know here dy by dx is written as negative of y square by x square, that is v square by u square. So here we can rearrange the terms and we can write dy by dt is negative of v square by u square into dx by dt. A negative sign is just giving us the idea about the direction of image is opposite to that of object. So velocity of image we can write in magnitude. Here we can specify that in magnitude velocity of image is v square by u square is m square times the velocity of object. This is a relation we can use when vu and vi are along principal axis, and this m square can be considered as velocity magnification for velocity of object along principal axis.